Hey guys, today we're going to learn how to create hard links and soft links, also called symbolic links, in Linux. We're going to talk a little bit about what they are also. We're going to tell you how to create them and what they are, cover some of the concepts and stuff. Hopefully this goes pretty quick and it's pretty easy. I'm going to show you how to create them really quick first in case you just want the quick answer. And then I'm going to show you what the difference is between them and a few other tips and hints and stuff. First of all, right, I'm inside this test directory right here. I'm just going to clear it out. So no files in here. Now we need a file to a source file, right, just to work with. So we're going to create an actual file. I'm going to call it sourcefile.txt. This is the file that we're going to be linking to. So there's our file, cat. It contains the word data. Okay, that's all fine and great. Now if we want to create a link to this file, we'll just use the command ln. ln with two parameters, the source file and the link to that file. So paste that in here, and we can see two files are here. They look the same, only the name of them is how you could tell the difference. So source file, link to source file, right? Now we're going to use the same command. We're going to have to change this command a little bit just so you can tell them apart. But to create a symbolic link or a soft link, so this first link we created above here is a hard link. Now the second link we're going to create is a soft link, also called a symbolic link. So we use the -s for symbolic. All right, run that. And failed because I didn't change the file name. It already exists. Okay, so we're going to change that to 2, right? All right, ls-l. All right, so we have 2 files, or 3 files. Okay, so we have the original source file, we have a hard link to that source file, and we have a soft link or symbolic link to that source file. And you can tell the symbolic link looks different because it shows this is just a link pointing to the original source file, and it tells you what the source file was. And the hard link doesn't tell you what it's pointing to. And I'll tell you why when I explain a little bit about how hard links and soft links work in just a second. But first, all right, so I'm going to cover the differences between these, but first I want to show you how you could create you could create things using the full path. So, all right, do I even have... First, I'm going to check that this file exists, and I'm going to try linking to it. So, all right, that does not. I'm just going to touch this file, just so we have a file to link to. Now, I'm going to create a symbolic link to that file. There we go. Now, all right, current.sh is now a symbolic link pointing to this, pointing to the full path of this file right here in my home directory. So that's all fine and great. Now, oftentimes you'll use that if you have a bunch of different versions of a script or piece of software. You're going to have like your QA version might be called like name of your software _QA. Or you might have the prod version or beta version or whatever, different links pointing to different actual versions of the software. That's one common use for symlinks. Now I am in the test directory, so we could use this command, but we're not going to go back 2 directories. We're going to go back 1 directory. So this would be the relative file path we're going to use. So this won't, so we're going to go like this. So we go back 1 directory and just act to my home directory and just create a link to this. We're going to create a different name because we already used this name, so just call it 2. And notice we do ls-l. Notice we have these 2 links. This one points to the full actual path, right? And so this one points to this points to the relative path, and we got the absolute path and the relative path here, and it'll actually show you in the link. Now this is useful if let's say if you had something, if you wanted to move this directory, like say if I moved this link to another directory, it would be pointing to the relative path from wherever it is, and that would actually break. So let's say if I moved current, move current to, let's move it to, let's just move it back to here, one directory back, right? Now current 2 in the directory below mine, and back in my home directory, it's pointing to something that's one directory beneath it with the name test1.sh, and or it's I'm referencing it one directory back. I could go back like this and just reference it like that. Now you see current 2 is pointing to something one directory back from where it is, which is not there. So that's the problem with an absolute path. But if both the file you're linking to and the link are together within a directory structure and that whole directory moves, you can preserve your links that way. However, if only one of them gets moved and the other it doesn't, then it's going to create a problem. So that's the use case for using absolute paths. And now if you had or that's the use case for a relative path versus an absolute path. So just something to pay attention to and think about. If you use an absolute path, I can move this link anywhere. I can move the link anywhere, and it's always going to point to this absolute path. Whereas if I move the source file, then this thing with the absolute path, this will break completely. Now with this one, if I move the link, it's not going to work. However, if I move if I move this, it's also not going to work. But if I move the directory that contains both of these, it will work. Now this, presumably, if you change anything in the path, it's not going to work. You'd have to move the whole file system. Just something to think about and be aware of when creating links, and when you want to think about portability and stuff like that. So if you're changing the whole directory and you have links inside it, it's moving that directory to a different disk or something, or renaming it. You're going to want those to be relative links. Anyways, hopefully that makes sense. Now let's finally get on to what hard links and soft links are and the difference between them. And then we're going to teach you how to find and delete all hard links. So deleting soft links is pretty easy, but deleting hard links is a little bit more tricky, and we'll show you why. Now, the difference between a hard link and a soft link. So basically what you get with so let's talk about this is a diagram here. Now on the top, this shows how hard links work, and on the bottom is how soft links work. Now basically a file name is just a pointer to some data on your disk. You have inodes on your disk in your file system, and a file name is just pointing. It's just a way to index it and tell you where that data is on the disk. So, and your file names are going to be, and all the data for them are all going to be managed by your file system, right? So the file name points to the data on disk. Now normally when you create a file, it creates one file name for that file, and that's a hard link pointing to the data on the disk. So this is just the name of a file pointing to the data on the disk. And a symlink is just a link. Now this symlink doesn't point to the data on the disk. This symlink points to the file name, and the file name points to the data on the disk, right? So if you delete the symlink, the file name still remains there and the data on the disk is still there. Now if you delete this file name, the symlink won't have anything to point to, and it's going to be a broken symlink. I'll show you how you can do that right here. Let's jump back in the test directory. Now let's see if we remove the source file, right? Now we can see it's red, it's a broken link. So that's what happens. You remove the file, and then you're going to have a broken link. The symlink is still there, but it's pointing to something that doesn't exist. It's broken. It can't point to the data on disk. If you remove the file, the symlink can't point to the data on disk. Now, deleting either one of these isn't necessarily going to delete the data, but you won't know where the data is. So once you delete the file name, deleting a file really just means removing the file name or the hard link for that file. And then in order to get that data back, you would need some data recovery software that understands your file system. So hopefully that makes sense. Hopefully I explained that well enough. Now let's jump on to hard links. Now hard links are basically just the file name that you that you use to refer to the data on disk, like I described below. Now when you create a hard link, you're just creating a new name for the same file. You're creating an actual link straight to that data on disk. So that's different from a symlink. A symlink, you link to the file name, which then links to the data on disk. When you create a hard link, you're creating, you have your original one, which is the name of the file when you originally created it. Then you have another, you create a hard link, you're creating another name for that same file, pointing to that same data. Now this hard link is just as legitimate of a link as the original file name is. It's basically just an alternate name for the file. That would actually make more sense if that's the name we used. Instead of calling it a hard link, you could just call it an alternate name for the same file. So you can delete this original name, and so long as you have at least one or more remaining hard links to that file, you can still access it. So long as you know what those links are, you can still access that data on the disk. Until you've removed all of the hard links to a file, that data is still going to remain there, or it's still going to be accessible. And even after you do delete them all, the data is still going to be there unless you overwrite that data. So long as that's the other thing I should point out. So long as you have at least one file name or hard link pointing to your data, the file system will ensure that other data doesn't overwrite it. When you write another file to your disk, it's not going to overwrite this data. But once you remove the last hard link, there's going to be no hard links pointing to that file. There's basically no file name for it, and your file system knows, hey, nothing's pointing to this. It's unallocated data, so we can use the space that was used by the file for new data to be written to. So once you remove all of these, that data is probably going to be there, and you could still recover it with file recovery software until you write new data to the disk. And when you write new data, create new files or expand existing files, there's a good chance that data is going to overwrite the space where this data existed, and it's going to remove that data. So yeah, just good to understand how that works. I'm going to show you how you can actually remove these. I'm going to demo hard links real quick. So let's clear this out, and I removed source file. Let's recreate that. All right, so there we go, source file. I'm going to remove current and link to file 2. And okay, so we have a brand new file here. And actually, you should point this out. All right, so I have some stuff about what is a hard link, and I'm going to demo them first. I don't know if there's extra information I should go over in these sections. If you want to find this document I'm reading on the right here, just check the link in the description. This is the guide I wrote to go along with this video. I actually wrote this guide first. So we have our file here, right? So technically this file name, we just created a new file, and technically this file name is a hard link itself. This is just the name for the file we just created, but that is actually a hard link itself. So it contains just this one string data test. So this is a hard link to the data on the disk, and this number here is actually the number of hard links to the file that this points to. So if I remove this, then that space that it uses can be freed up and used for other things. The data will still remain there until something else comes along and happens to use that space on the disk. But let's say if we go ln, let's just call it 1, just to keep things simple, or 1.txt. Okay, and we're going to say source file. So we're going to create a hard link called 1.txt, and we're just going to use ln with no other parameters. And let's take a look now. So notice the number under source file has incremented to 2. And same deal with this. So now this file name and this file name both reference the same data on disk. Both of these file names are for the same data on disk. They're basically the same file. They actually are the same file on disk. So you can cat either of these, cat source and cat the cat 1, and they're the same data. Now it's not a copy of the same data, it actually is the same data. So you could say echo echo some more stuff over source file. Right now, cat that source file. It contains some more data, and you could cat the hard link, which is an actual file, and there you go, same data. So you write to that file, and it writes to the other file. It's not a copy; it's the actual same file, and you can tell this file has 2 hard links, and this has 2 hard links. Both of the hard links are the file names you see right there. I apologize if I'm repeating myself too much. I just want to make sure I'm explaining this clearly, because it's sometimes people can get confused about this really easily. So let's create another link. ln source file. Whoops. We're going to call this 2.txt. Now, notice the number incremented to 3. Now we can also say ln, and we could just say ln2 3.txt. So we can create a link to 2, and that's the same thing as creating a link to any of these others. So create that link, and ls-l, all right, here we are. Now we look at these files, and this actually has 4 hard links. That's the number of hard links. So we know somewhere on our system we have 4 hard links to this file. Now we could go back a directory, and we could say ln test, and we could say source file, and we could say 5.txt, and we can say, and here it's going to tell us we have 5 links pointing to this 5 hard links pointing to this file. Now that's not the count of symbolic links, it's just the count of hard links. So let's go back into test, and as we can see, we only see 4 files here, but we can see there's 5 hard links to the same file. So that hard link could be anywhere else on your system, and you would have no idea where it is. So if you actually want to delete this data, let's say if these were really big files and you wanted to delete them to clear up space on your hard disk, I guess you could search for whatever's using up space, but deleting all 4 of these files would not clear up the space, because there's still another file in another directory eating up that space, or another reference to that same file. So it's not going to be deleted, and it will still be eating up space on your system. So we can also, let's see, we can, yeah, and we showed deleting these doesn't delete the original file. Did I delete any of these? I haven't. So I can remove the source file, and we can check that reduces the number of file. So that source file is gone, but we still have 4 hard links pointing to this file. So 3, and they contain the same data, right? So you could say the data is still there, untouched, and we can still work with it. So nothing has happened to our data at all, even though we removed that. We removed the original name for the file, but the file and the data are still there until you remove all of these links, right? So now we can actually create a symbolic link to one of these. Whoops. And there we go. So we can create a link. Now we're seeing that this is a symbolic link pointing to 3. It could just as well have pointed to any of these, and it would work just as well. Now we could cat this out, and we can see we can access the same data with the symbolic link, but notice creating a symbolic link won't increase the number of hard links. So you don't have a way to really track how many hard symbolic links there are. So let's see, there's a way to find these. Now before I do that, let's talk about what is a soft link and a symbolic. I think I've pretty much covered this, but let's see. So also referred, blah, blah, blah. Removing a soft link will not delete the original file. Okay, you can remove that. Removing the original file will not delete the soft link, but will result in a broken link. Okay, we've covered basically all of this in great detail. Hard link is basically the same thing as the original file name. Deleting the hard link. All right, yeah, we've covered everything in these 2 sections. Just wanted to make sure I've covered everything that I put in here. All right, that's pretty much it for that. I'd like to show you how you can find and delete all hard links. So you could find all hard links. I'm not sure how fast this is going to be on my hard drive. Let's try finding them. All right, you know, we're just going to search in my home directory. Now you can use the find command and you say same file. Now one way to look at it, instead of saying they're different names for the same file, or that they're hard links, these literally are the same file. 1, 3, and 2 are the same file, and also that other one that we created in my home directory, whereas my stupid symlink.txt is not the same file, it's linked to the file. But these names here are literally all the same file. So when you use the find command, you specify the directory you want to find in, and cross device. I believe this, I forget what that parameter does, but you need that. And same file, you specify same file, so it's going to look for everything that's the same file as this right here. Now we're going to change the name to one we want to look for. So we want to look for everything 1.txt, anything that's the same file as 1.txt in my home directory. And that ran pretty quickly. That's kind of nice. So even though our current directory only has 1, 3, and 2 in that symlink, this returned to us 1, 2, 3 in the current directory, in the current test directory, and it also found 5 for us in my home directory. So that was kind of nice. So we could also specify, if you wanted to search the entire system, this will probably take too long. You could just specify the root directory, and there's a bunch of things I don't have access to, and it's going to take a while because this is kind of large. I don't think using sudo would speed that up too much. Actually, that was pretty quick, searching my entire system. So yeah, if you don't use sudo, you're going to have permission denied errors on a ton of stuff, and it's going to hang on some things. If you use sudo, then no problem. You can actually, it searched my drive pretty quickly, but that's because it's a really fast SSD. Anyway, so if it came up with the same results across my entire drive, this is the number of hard links for this drive. So I was able to find all of the hard links on my entire system for this one file. So if you want to actually delete all of these, you can you can pipe this same thing to xargs rm. Now you technically don't need to use xargs. If you know you only have a few of these, you can just pipe it to rm. Actually, I'm not sure if the pipe would work. I would have to test that out, but xargs will handle a large number of arguments. Let's just try this. Pipe it to xargs rm. And there we go. Let's try to search for it again. I can't find it because there's nothing. So in the current directory, no files except a broken symlink now. So I successfully deleted all hard links to a file. So, you know, if you wanted to make sure you got rid of all of them and clear up all the space or whatever you're attempting to do, you can just say sudo find and the file system you want to search on or the directory you want to search from, xdev, same file, specify the file, and pipe it to xargs rm, and that's going to search for all of them and delete them for you. Now I'd like to try again. Test 1. All right. Now I'd like to say ln test 1, test 2, 3. Oops. 3, 4, 5. All right. So there we go. We have 5 hard links right here, and I'd like to try this command again. So let's try. Let's just try running xargs. Now change the file name to test1. Right. So anything that's the same file as test1. I'm gonna try removing it, but I'm just gonna pipe that to rm without xargs. Hopefully this doesn't do anything unexpected, but let's just pipe it to rm. All right, so missing operand, it does not work. So I guess you can't pipe parameters into RM in the first place. If you could, it would be able to handle it fine because it's only a few. Normally you use xargs to handle a large number of arguments. That is too much for a single command to handle. But also xargs allows you to pipe in parameters as well. Now the find command also allows you to run a command. Let's show you how to do that. So almost the same thing you can do. You can actually specify command in. This is kind of getting off topic, but worth noting. Another common way to do things, you can tell find to execute a command also. So you can say exec rm, and put some curly brackets here, and then just slash semicolon or colon. All right, anyway, run this, and there we go. We can see all the files were removed. So basically what this is doing is it's finding all the same files, all the files that have hard links or that are a hard link to this file. And same as we did before, but instead of piping it to xargs, we tell the find command to run exec to execute a command. We tell it to exec the rm command, and anything in the curly brackets, basically the curly brackets get replaced with each of the items that it finds. So the find command basically finds a list of files, and it passes each one of those to the rm command in place of the curly brackets. So it's running the rm command a bunch of times. And this, I forget why you need this, but this is just necessary syntax. I believe it's just an escape character. And yeah, anyways, that's why that's there. But I think that's everything I wanted to cover with this. Basically, we went over how to find and delete all hard links, what a hard link is, difference between a hard link and a soft link, and all the concepts. I think we've pretty much covered this in as much depth as we could possibly want to cover it in. So hopefully you found this useful, or at least interesting. If nothing else, you might want to give me a thumbs up. You might want to hit that subscribe button also, and hit the little bell icon. Otherwise, YouTube's probably not going to let you know when we come out with a new video. We do have a lot of great stuff coming up, and we've actually, if you want to check our list of videos, we've already put out a lot of pretty interesting things, some more interesting than others. We cover a lot of great stuff. Coding, servers, hardware, software, 3D printing, electronics, single board computers, robots, networking, all sorts of great tech related stuff that you're not going to want to miss. So if you want your YouTube feed to be that much more interesting, you're going to want to hit that subscribe button. But more important than any of that stuff, you're going to want to leave a comment down below, especially if you know something that I don't know. Definitely let me know, not just for me, but for the next person who comes along and watches this video and reads the comments. Leave a comment for them also. Any comments, questions, criticisms, whatever you want to say, I probably want to hear it. So do leave a comment down below. And that's pretty much it for today. So as always, thanks for watching, and we'll see you guys next time.